This conference will now be recorded.
What is a string?
Collection of characters.
Collection of characters, array of characters, right? So, string is a collection of characters. String is not a primitive data type. It's an object reference data type. Okay. So, string. So normally you can declare like this: var string, var or val, variable name, and you can specify the data type and directly you can write a string in double quotes, right? So, um, strings are immutable. What is immutability? We talked about immutability a lot. What is immutability?
Once a value is assigned, it cannot be changed.
Okay, once now we declare the value, once we declare the string, and if we try to do the modification, either converting into uppercase or adding something or deleting something or removing, so reverse or whatever you do, the operation, so that will not be modified. So instead of that, it will create a new object. Instead of that, it will create a new object, right? That's called, it is called immutability. So here we need to understand. So as I said, since it is a reference data type, if you declare a string like this, if you declare a string like this is called string literal. String literal. If you declare a string literal, so what will happen in the background? In the memory, there are two type of memories: string constant pool, string constant pool, and normal memory, normal heap memory. So what is a string constant pool? What is a string constant pool? Let me explain that. Okay, let me draw. One second. In the heap memory, there will be separate space for strings. There will be separate space for strings.
Praveen, we cannot hear you. Hello.
Iravi voice is not audible.
Hello, Ravi. Ravi, we cannot hear you.
Hello, hello.
Yeah, yeah, we can hear you now.
I don't know what was the problem.
Since you started making this diagram, we were not able to hear you.
Is it okay? Okay, let me repeat it. Let me repeat it. Let me repeat. Okay. Let's assume that it is your memory is the square box. The square box is your heap memory. If you assume it's your heap memory, and in that whatever the circle you see, it's a string constant pool. It's a separate memory. We'll call string constant pool. It's called string constant pool. Okay. What is the string constant pool? It's a separate memory for the strings. String literals. I can say when I say strings for the string literals, I'll show you what is a string literals and what is a string object. Okay. Let's say if I declare a variable call, if I declare a variable call where name equal to course, name equal to scala. Well, name equal to scala. So what will happen here whenever you declare a name equal to it's a string, right? So it will not directly go ahead and create an object. It will not create. It will not go ahead and create a string object. What it does, it will first look for whether the string exists or not in the memory. First, it look for whether the string exists or not in the memory. First, it look for is the string is exist or not in the memory. If it is not exist, then only it will create. If it is not exist, then only it will create like this. After creating this will be referred by your name. Okay, let's assume that I have declared one more variable. I have declared one more variable called scala. Course equal to scala. This time again it will check for is the string is already exist or not in the memory. Is the string is already exist or not in the memory. If it is already exist, if it is already exist, it will not create a new one. So whatever is already there in the memory, whatever is already there in the memory, it will make use of this. That's the advantage of the immutability. That is the advantage of the immutability. Okay, let's assume that now if I go ahead and modify an existing object, if I go ahead and modify existing object, let's assume that I'm going to change course equal to course dot uppercase. Let's say if I declare course equal to course dot uppercase, so what will happen? The course will be, the scala will become uppercase, correct? Yes or no? The scala will become uppercase. So the uppercase scala is not exist in the memory. Uppercase scala is not exist in the memory. So what it does, it will create one. It will create one. Then this time what will happen? It will the existing object will not get modified. The existing object will not get modified. Instead of that, it will create a new object. Instead of that, it will create a new object. Instead of that, it will create a new object. When it creates a new object, it doesn't mean that the old object has been modified, right? Since it is immutability, what it does, whenever you do the modification, instead of modifying the existing one, it will create a new one. If it is modify the existing one, this could have been impacted, right? The name could have been impacted. Okay, so that's the reason we'll call it is a immutabilities. These are immutables. These are immutable. Strings are immutable. If you do any operation, you concatenate, or reassign, or reverse, or delete, or remove some characters, whatever you do, whatever the operation you do in existing object, existing scala or existing string object, it will get modified. It will get it will not get modified. It will create a new one. It will not get modified. It will create a new one instead of. Is this clear, guys? Is this clear? Let's look at here.
Yes, Ravi.
Yeah,
Let's look at here. So string name equal to scala. If the scala is already exist in the my memory, see when this we need to remember one thing. When this all variables or whatever your assignments or whatever the operations will be performed at the time of running, when the program is running, what will happen? It allocates some amount of memory from my RAM, right? It allocates some amount of memory from my RAM. So whatever the RAM, so there will be something called Java virtual machine configurations will be there. What is the minimum virtual memory it can make use? What is the maximum virtual memory it can make use from my RAM? In that memory only, it will allocate some amount of memory for this. Okay, while running what it does, so I have declared scala in this program, right? It will check that is there a scala is already exist in the memory. If it is not exist, then it will create. If it is exist, it will refer the same one. You may ask, sir, if it is refer the same one, if anyone modify that existing one, it will be impacted? No, it will not be impacted. Because the strings are immutable. It is not going to modifiable. It's immutable. Instead of modifying itself, it will create a new one. Okay, so look at here. I have did the scala and I did the concatenation of this. Here the original scala will not be modified. It will be created scala vira with a new one. It will be created scala vira. So after concatenating, it will come as a scala vira. If I print this, it will give the scala vira, which is a new object assigned to name. Let's look at this. Scala. So if you look at here, scala vira, it's a new string assigned to name. It doesn't mean that the older one has been modified. Okay, is this clear? When you do the any modification, it will not get modified. It will create a new one. Okay, so you have a lot of operations in the strings. Let me show you kind of some of the operations. Can I say name dot? You can press tab twice, so you'll see all these are all the thing. Add string, aggregate, apply. These are all the string operations. They're all the string operations. So few of them we will see. Okay, length, uh, equal, reverse. A few things we'll see. Let's look at. The strings will be declared like this. Quickly take an example. Most of the time we will be using this substrings or concatenating converting into uppercase and concatenating another thing like that. Please make a note of it. Please make a note. It's a bigger string. It's a bigger string. So we have broken into multiple lines. It's a broken into multiple lines. So if you observe here closely, this plus symbol is what it does. It is concatenating. It is concatenating. It is one string. This is one string plus this is another string plus this is another string. Okay, if you declare like this, what will happen? If you declare like this, what will happen? In the memory, in the memory, in the memory, this will be created. This will be created. This will be created, and there will be won't be any reference, and there won't be any reference because these are all the strings which will be created with no reference, like no objects with no reference. So what will happen after some time? The garbage collector will, if the no one is using them, so the garbage collector will come and remove them. Okay, so here this is the one string plus another string, another plus. So combination of all these strings again will be created one string and will be assigned to this. So if I declare like this, four objects will be created, guys. If we declare like this, four objects will be created. One object here, another object here, another object here. Three objects plus combination of all, one object. Combination of all, another object. There will be four objects will be created if I declare like this. Okay. So what is the purpose of declaring like this? Because I want to, it's a very biggest string. I want to break into multiple lines. That's the reason. So for this reason, Scala come up with something called multi-line string. This one. You can declare like this. Instead of breaking it to multiple strings by concatenating plus symbol, you can use a triple quote to declare a multi-line string. To declare a multi-line string. Normally the string will take a single line only. It will not take the new line character in it. Okay. If you want to multi-line string, you have to go with the triple quotes. Please make a note of this triple quote one. So multi-line string it is. Okay. Let's take triple quote one. Okay. Now this one also triple quote one only. It is not a multi-line string. Yeah, it's not a plus concatenation one. It's a multi-line string. Okay. If you look at here, if I look at here, okay. Let me show you an example. I have declared a value x equal to 100. I declare a value x equal to 100. So when I print like this, what will happen? Let's look at here. Println value x. It is showing 100, right? Let's say I want to concatenate the I want to sum the x plus x. Okay, if I do x plus x, can anyone tell me what will be the output of this? What is the output of this?
It will be concatenated.
It will be concatenated. It will not be it will not does the your
Sum.
sum. Arithmetic operation will not be performed here. Can anyone tell me why? Can anyone tell me why?
I think the argument will be string type in this println.
Yes, for this println method, the arguments are string. So and also you are doing concatenation with the string. When you're trying to do the concatenation of the string, it'll remaining characters, remaining variables also will be considered as a string. Remaining variables also will be considered as a string. Look at here, 100 plus 100, 100, 100. It given 100. It means it's considered as a strings and concatenated. Okay, be careful while you are doing this kind of operations inside the println statement. Inside the println statement or with the string or with the string. If you are doing it with the string, so please be careful with that. Okay. Okay, let's move on to this. Okay, let's look at here. I have some float variable, I have some int variable, I have some string variable. Okay, so look at this. I have a three variables: float variable, string variable, integer variable, and string variable. Now what I'm going to do here is I'm going to concatenate all of them. Normally I want, my intention is float plus int plus. After these two, if I do the concatenation, it has to do the arithmetic operation and it should be concatenated. Okay, like this. If I do like this, everything will be considered as a string. It'll just concatenate. It will not do the arithmetic operation. It will not do the arithmetic operation. It will just do the concatenation. 100 x is 100, and the float val is a 12.45 and 12.456. I think 12.456, and integer value is 2000. So when I did all this, it has been concatenated. Instead of doing arithmetic operations, it has been concatenated. Okay, if I do the same operation outside, if I do the same operation outside, if I do the same operation outside, let's look at here. If I do the same operation outside, not inside the println, normally it's concatenating. Arithmetic operation is did. It did arithmetic operation. 2000 plus 12456, 2000, 2000 12.456 plus 100. That's the reason it's a 2100 12 4.6 456. Okay, then to declare these kind of operations, suppose if you want to perform these kind of operations, so we have a different kind of strings. We have a different kind of strings, different type of strings. The way you declare. Okay, let me show you that. This is formatting, so not this one. Let's say, okay, let me explain this also first. No problem. So there is something called printf. So far we have seen println, print, then go to the next line. That's a println purpose. Print, then new line. Print, then new line. That's called println. But here printf, print then format, print format. So this is going to format. How? Look at here. The value of the float variable is percentage %f. I have declared percentage %f, while the value of the integer is percentage %d, and the string percentage %s. If you look at here, if you look at here, I have a three different variables, and I'm the printing. These are printing for format, nothing else. Those are printing format. Okay. So if I want to print the same thing, normally what I will do? If I want to print the same thing, what I will do in the println? So let's look at here. If I want to print the same thing here, println. So here let's remove this. What I will do? The value of the float variable is, I did the plus here, right? Then I'll just declare the variable name. So float variable. Then I'll do the plus. Then I'll remove this f. I don't need it. The value of the percentage. So when I do the this one, right, what I'll do, I'll close variable here and do the plus. Then I'll start here for them. Here, what I do, I will give integer variable. I'll give the integer variable. You understand what I'm trying to say here? So you can write a string like this. You'll write a string like this. Okay, but when you write the string like this, what will happen? The values also will be considered as a string, part of the string. But if you do the format, you can use the percentage %f or percentage %d or percentage %s for the string. So based on the type, F means floating point, D means digits, S means string. So based on the type we use, so we can declare like, you'll see the difference. Let me complete this one also. String plus string variable. The value of the float variable is this, and while value of this is integer value is 2000. So it came like this, right? So if you do, you have a different approach. This is called printf. Either you can do both the ways. You can directly print like this, you can directly print like this, or you can assign to the variable also. Okay, it is formatted. It's a printf. It's a formatted. You can also assign to the variable, and you can print. It's not returning anything. Fs is not returning anything. That's the reason it's just given the bracket. So you really no need to assign to the variable. This is another type of method, format method. So same thing, I'll show you another way. Okay, let me show you another way. There are different type of strings called string interpolation. We'll call string interpolation. Look at here, string. If I do this one, we already seen. Okay, it'll instead of modifying, it will concatenate. Okay, this one we'll just print, but it will not do the arithmetic operations. It will just print. If we take this one example, x comma y, and we'll try to do this operation. It will consider as a strings only. It will not be considered as a integer variables or integer values. It will be considered as a strings only. X value 100 and y value is 200. X plus y equal to 300 supposed to be, but it is giving 100 plus 100 to 100. It means it's concatenated. So if you want to do such kind of operations, we have something called the expressions like this. Expressions like this. Okay. So if you use the expressions, look at this operation. This now it will not be considered as a strings, it will be considered as a variables, and it will do the operations. It didn't do, right? Since we have used the plain string, it didn't do any operations. It's just printed as is. So there is a some small what is something called if you assign like this, s before the string, if you declare s as a string, okay, if you declare s, now you'll look at this s, and let me assign to the variable val r is equal to, I'll put like this. Now look at, yes, if you, even if you don't use this kind of expressions without s, without s even if you use the expressions without s, it will not be considered as the expressions. It will not be considered as the expressions. If you use s, then it will be considered as the expression. If you use s, then it will be considered as a expression. So if you use the expression instead of whatever the values you declare inside the println or inside the string, they will not be considered as a string, it will be considered as a variables, and it will be replaced, and it will be actually considered as a uh, I mean variables, and what expressions it will be considered. Okay, this is called string interpolation. S is represent the string. Okay, so not only yes, there are some other different values different types as well. Let's see them. S is one of them. Okay, let's look at here. So if you use s, it will be considered as the expressions, and it will be replace the values. Dollar x means x value, dollar y means y value, dollar and expression, this is an expression in the curly braces. If you do any operations, arithmetic operations, it will be considered as the expressions. Okay, so this one I'll explain later, because to make you understand what I'm actually doing here, it is something like object. I'm creating an object, a book object I'm creating using a new keyword. So since I haven't covered the class object and the part, we will discuss this later. Very simple expressions only. These are also expressions. Object dot variable, object dot variable. So nothing else. Object dot method, object dot variable we can do. It means in this expression you can do any operation. Okay. Next, look at here. F. We already seen this. We have already seen this, right? Let's look at here. Let's look at here. This is my book price. This is my book price, and I'm printing that value. Look at here. What will happen? I want to print the decimals of dot. After dot, I want to print the decimals. Look at here. What will happen? It's not printed. So dollar book price is, it's replaced the book price 100.5. It replaced, but my intention is I want to print the decimals also, decimal values also. After the dot, I want to print two decimal values. It's not, it didn't consider. So even though if I use S, it didn't consider. But if I use F format, if I use F, look at here. Here I have mentioned 4. You can mention 2 also. Look at here. After decimal, I want the 4 digits. After decimal, I want the 4 digits. So we can use F. We might have used these things in C language in earlier days. Printf, scanf. That time while we were printing the values in printf, so we might have used this percentage %d, all these things. This is format F, using format of your string. Okay, please look at the differences. One is S for a string, it's a string interpolation. S, it replaces your expressions and replaces the variables. And other one is a F. F is nothing but format. Okay, you can use a printf, or you can use simply F. You can use the printf, like as I explained before. You can use the F, or you can use the printf. Printf also does the similar one. Okay, next, ra. There is something called ra. Look at here. Before the string I have mentioned ra. Okay, to execute this, I have to create these objects. To create this object, I have to create this book. Let me create a book first. I'm creating a class here. So my class is defined, class book is defined, and I'm declaring a couple of variables. I can call them as objects. Two objects has been declared, book 1 and book 2. Two objects has been declared, book 1 and book 2. And I'm trying to do, let me show you ra. Here I'm using okay, before that let me let me do this thing. What will happen in the string interpolation if I use /n? In the format, if I use /n, in the, what will happen? Let's see. These are normal variables. If I go with the string and I'm using /n here and /t here, the escape sequence characters, let's look at what will happen. Yes. Any guesses what will happen if I use /n? What will be the output of this? Look at here. Book details, it came to next line. Name, /book I did. So what are the book? Scala cookbook. I have mentioned Scala cookbook. Then tab, look at here, tab. Look at the tab. Then again author. Then again tab, the price. Look at here, book details. Whatever the escape character I have used, respect to value get replaced. /n means new line, /t means tab. So those has been replaced, right? Let's do the same thing with F. Here I'm using two decimal. After decimal, 2 digits I want. Book price. You got it? Book details, book name, author, and price. Price you might have seen little difference because I have used dot to F. This means after dot I want 2 digits. Okay. Next, look at this. Ra. What will happen? Ra. If I do the Ra, if I use the Ra keyword, if I use the Ra keyword, look at here. I don't want to replace this escape sequence character. Slash n as is print. Slash t as is print. Remaining values will be replaced. Okay. Dollar book means book is replaced. Dollar author means author replaced. And here I have used format. Okay. F I have used here. If you look at here, F I have used. That's the reason it is printed this way. Otherwise, it could have not printed. Okay. Is this clear? The differences between S, F, and Ra. This is little important. We will be keep using them in the real time. Please make a note of these things. S1, one is S, other one is F, other one is Ra. You can take this for. Okay, have you taken this example? Let's move on to the next. Anyway, this video will be uploaded and you can look at it. Let's look at another example, and there are some methods. Okay, before that, let's look at the immutability, string immutable, and these examples. Okay, we'll see the string comparisons. We'll see string comparison, how it will work. We'll see. Okay, look at here. I have a name. I have a course. Can anyone tell me, is it created two objects or single object? As per our discussion, since
Single one.
it will create a
Single
single
object.
object. So string constant pool, it will created a scala object. If the object is already available, it will refer that this is what we discussed, right? Let's look at here. What will happen? Name, course, S. We have a three different objects, but the content is same, but the objects are different way we created. This is if you look at the line number 9, the way I created object is different using new keyword and string constructor. If you see that line number 9 and compared to the 6 and 7, 6 and 7 are liter I'll call as a string literals. It means there is no new keyword and I haven't used any class or object, class or constructor. But if you see the line number 9, this is the different way of creating a string. So using a new keyword, when I use a new keyword, what will happen? It'll call the constructor, then it'll call some memory allocation, or all will happen, right? Look at here. Look at here. I'm going to copy this too. I have created three strings. All are having the same value. Small letters only, scala. Okay, let's look at this. There is something called hash code and equals. There are some methods will be there. Hash code is the one who actually going to provide you unique code for every object. Hash code is nothing but a unique code for every object. If you guys remember, we discussed a lot about hash code in the bucketing. We talked about the hash code in the bucketing. Okay, let's look at this. Look at this. The hash code is same. The hash code will be created based on the content. Okay, based on the content, the hash code will be created based on the content. That's what we discussed in bucketing and other stuff also. The hash code will be created for every object, right? Look at the hash codes of all of them. Okay, next, look at here. I'm going to do comparison. Name, course, name, s, name, eqs. Look at this, what will happen. I'm going to execute this. I'm going to execute this. I'm using equal symbol. Try to look at. I'm using equal symbol. What is the output of this? Name and course are equal. Name and course both are equal because they have the both same content. Same content. And look at this also. Name and s. Name and s. S, another variable. Name equal to s. Yes, both are equal because both has the same content. Both has the same content. Get now. Name dot eq s. This time instead of equal symbol, I'm using some function called eq dot eq. I'm using instead of equal symbol, I'm using eq. Reference and name, reference name and s are not equal. Not equal. Look at here, guys. Name and s are earlier when I do that, it's equal. Content is equal. Content is equal, but objects are different. But objects are different. Different objects, different references, different references. Let's look at now. Name and course. Name and course. Name and course. We have already seen name and course were equal earlier. Name and course were earlier equal. Name and equal were course. Name and course were equal earlier. Now look at here. Now also equal. Now also equal. You guys understand what I'm trying to explain here? If you declare a variable with the string literal, if you declare a variable with the string literal, name and course, let me explain this, what happened in the memory. Let me explain this. Let me explain what is happening. I have declared three variables, right? Name equal to scala, course equal to scala, one more variable where s equal to new string of scala only. New string of scala only. So what will happen in the memory? First, when I'm declaring name, it will look for the string is already exist in the memory or not. If it does not exist, it will create one. It will create a scala. Then when I'm creating next another course, it will look for this. Okay, is the scala is already exist? Yes, it is already exist. So let's refer the same one. Let's refer the same one. Okay, it means Name and course both are referring to the same object. Name and course are referring to the same object. Okay, now let's come to this part, new. So when you use the new keyword, right, it will not create object in this circle one. It will create a different. Let's say here it will create here. It will create here. Then it will be referring by name. Sorry, yes, it is yes, right? It is yes. It will be referring by s. So if you use a new keyword, it will not create object in the string constant pool. It will not create a object in the string constant pool. It will create outside the string constant pool. Outside the string constant pool. Now, when I compare, look at the first comparison. When I compare name equal course, yes, they matched. Content, scala, course, both the content is same. Next, when I compare, even reverse also, if I compare this way or if I compare this way, both are same. Okay. Next, name equal s. Name equal s. Try to look at the operator what I'm using, guys. That's important. Name equal s. Yes, content is equal. Here also scala only, here also scala. Content is equal. If I compare like this or if I compare like this, both are equal. Okay. Now, another important thing is name dot eq dot eq. Eq actually represent references. Are they referring to the same object? Are they referring to the different object? The meaning of eq is reference comparator. It is reference comparator, not the content comparator. Content comparator is equal is over. It is eq is the reference comparator. So is the name and s both are referring to the same object. That's the meaning of it. Is the name and s are referring to the same object. That's the meaning of it. Are they referring to the same object? No, they're not referring to the same object. They're referring to the different objects. They're referring to the different object. That is the reason you saw here the false. Is it equal name equal eq is both are referring to the same object? No. A reference and s, reference name and s are the references of, okay, references of name and s, references of name and s are not equal, because they are not referring to the same object. But name and course, the references of name and course are equal, because both are referring to the same object. They both are referring to the same object. Understand, guys? So you understand now? If you declare a string literal way, it will create a different location. If you create with a new keyword, it will create a different location. Even though the content is same, but references are not same. Even though contents are same, but references are not same.
Ravi, I have a doubt.
Okay.
Starting we mentioned like name equal to scala and name dot content equals to Vera, right?
Name dot
Name dot content.
concatenate. Concatenate.
Yeah.
Mm.
Yeah, here how that will work?
It will create a new object. It will assign to that.
Okay, but it was printing scala only, right?
Where it is printing, I have not done any concatenation, right? Did I do any
Name dot
concatenation here?
concat of Vera you did, right?
I have not done here, right? Where is in this program where I did?
Not here. Not here.
Uh,
Initially you were showing, right?
that will be created different one, right? That's what I'm going to show you. Name equal to name dot concat. I'm doing Vera. Okay. Now my name is changed. Okay. My name is become Scala Vera. So if I compare these things, what it will print? What it will print? Are not equal, right? The name has been changed. The name and course are not same now because name value is changed.
Can you print the name value alone without concat?
You already changed it, right? You already changed here in the line number, not line number here. You already changed. How can I print it again? If you want to see, you can see here name alone. This is the name alone. I didn't get you. What is your confusion?
My confusion is like you told it is immutable, right?
Correct, ma. I didn't modify anywhere here, right? This is my name. This is my course. This is my yes. I haven't modified anywhere. Did I modify anywhere?
Then now if we'll print name, what it will display? It will display Scala Vira or
Why it will display Scala Virama? Okay. Okay, let me run this program. Try those experiments at later, okay? Hmm. Let me run this program. Value of name, Scala. Value of course, Scala. Value of S, Scala. Okay? You understand?
yeah.
Gautami.
Yes,
Name,
Ravi.
course, these are all printed, Scala only. Okay, next what do you want me to do?
You concatenated, right? That
I have not concatenated. You want me to concatenate now?
okay. Name
No, here I
equals to
have,
not concat of.
in this program, I didn't concatenate it. You want me to concatenate now? That's what my question is.
Yeah.
You want me to
Yes.
concatenate? Okay.
Yes, Ravi.
Name equal to name dot concatenate. Okay. I mentioned Vira. Okay. Now we want me to
Okay.
print name.
Yeah.
It will print it. It will print Scala Vira only.
Mm,
Okay.
It changed the content, right, Ravi? Then how it is immutable?
That is what I was keep on telling you, right? I'm reassigning here. I'm reassigning. Do you see? I reassigned.
Okay.
So it created a new string here. It is created a new string and assigned to this. I created a new string here and assigned to this. That's how it is. That is the reason it is changed. That's what I was explained earlier, right?
Okay.
When you do the concatenation like this, name dot to upper or name dot upper or whatever you convert or concatenate, whatever you do, what is I'm doing here? I'm changing the reference, right? So it will create a new object with this. It will create a new object with this. It means Scala Vira. Let's assume that it is a Scala Vira. it will create a new object. Then the reference will change. That's what I was telling you, right? And I will have removed the reference also here. The reference also changed. Now course is referring Scala, name is referring Scala Vira.
Okay, Ravi,
You
I
understand?
understood. Yeah.
Okay. Okay. So since I have changed name here, always all this will be false. Okay, this will get changed. So name and course are not same. Name and course are not same because name is Scala Vira, course is different. So they're not same. Okay, and name and as are not equal. So these all will get changed. So just let me remove it. Let me comment this. Is this clear to everyone? If you declare a variable like this and if you declare a variable like this, there's a huge difference. Okay, they will not be referring the same object. So that's the reason I try and showing you the references will be different. The references will be different. If you declare using literal way, like line number 6 and 7, they will create in a different location. If you create object using new keyword like line number 9, it will be created in different memory. So the references will be changed. The references will change. Okay, references won't be same. So that's the reason your S and name, these are all same references objects. Okay, and again I have used some more examples here. Name equal to name plus spark. Name plus, I can use a plus, I can use this. Then look at here, I printed the name Scala Spark. Okay, but hash code, if you look at the hash code got changed. The hash code got changed. So earlier, what is the hash code? It is the hash code of the name. Hash code of the name is 1092508886, and here the hash code of the name, now it is changed because I have changed the content. I have changed the content, so hash code also will get changed, obviously, right? So if the content is changed, hash code also will get changed. Okay, next, there is something called string buffer, like how we did the array buffer yesterday. There is something called string buffer. Strings are immutable. To get the mutable strings, we will go with string buffer that we will see in the next session. Any questions? Please ask me, else we can leave for the day. No questions? Yeah, we can leave for the day, guys. So we'll connect in the next session.
Yeah, thank you.
Thank you, guys. Thanks for your time.
Thank you.